In this video, we'll cover the basics of ionic bonding in chemistry. To do this, you're going to need your periodic table, and for a few of the questions, you'll need a little table that's got the valency of the common polyatomic ions, which is that little table over on the right. To get yourself started, you should set your periodic table up like we did in the previous video, with the little valencies written up the top, and that's these numbers across the top here that we've written in. Valencies at the top tell you whether you are looking at positive ions, which we call cations, so I've coloured those in yellow, or whether they're negative ions, which we call anions, which I coloured in green. And the basics of ionic bonding is that one of those elements that I've coloured in yellow, the cations, will want to form a bond with one of the green ones, the anions. And our job is just to work out in what ratio they like to stick together. So by writing those little orange numbers in, that will help you to work out quickly in a test how many bonds each of those elements is going to want to make. Now, the other important group that we have to talk about here are the noble gases. These do not form bonds, so it's strange that we're talking about it during ionic bonding, but we know that atoms are made up of protons, neutrons, and electrons. The noble gases, those ones I've just coloured in pink, those ones have the perfect electron arrangement. They've got a perfect outer shell, so that means that they never want to gain or lose electrons, which is why they don't like making bonds with everything else. And if you think about it this way, every other element in a periodic table is aspiring to be like that, which is why they form ions. They're trying to get a complete outer shell, either by gaining or losing electrons, and in the process, they end up forming an ion instead. And we'll have a look at an example of that. Sodium meeting chlorine is a really good example of ionic bonding. Sodium is, for starters, an interesting example because you definitely wouldn't want to eat sodium. It's an alkali metal. And chlorine's a poisonous gas, you definitely don't want to breathe that in. But when they bond, they form sodium chloride, which is just table salt, which you can put on your hot chips and eat. But if we've got to get them to meet one another and see what's going to happen in an ionic bond, go and find them in the periodic table. The first trick is that they're likely to be in the first 20 elements. That's where they're going to be asking you questions in a test. So don't spend a lot of time looking through the whole table. They'll be in the first 20 elements. And remember, you find those by having a look at the atomic number. So there's sodium. The first thing that we notice about sodium is that it wants to make one bond, because we made ourselves that little note earlier. And we can find chlorine over here, and it also wants to make one bond. We made that note for ourselves a little bit earlier. But what that means in practice is if you have a look down here at this table, sodium has got one electron in its outer shell, and remember, it's aspiring to be like the noble gases, so it wants to either give that electron away or it wants to gain extras to have a full outer shell. And similarly, chlorine on the right there, it has 7 electrons in its outer shell. It either wants to give those electrons away or it wants to take them. And the way that elements work, or atoms work, is that they'll do whatever's easiest. So sodium will give up that 1 electron to fall back to having a full outer shell, and chlorine will gain an electron rather than give 7 away in order to do that. So it will look like this. So both these atoms now have full outer electron shells, but when they did that, they either gained or lost electrons, and that made them form ions. So sodium on the left gave one of its electrons away. It now has 1 fewer electrons than protons, giving it an overall positive charge. And chlorine has gained 1 extra electron, so it now has 1 more electron than protons, which gives it a negative charge. And it's this positive and negative charge that forms the ionic bond, and that's why these two elements have now joined together. Have a look at what it looks like if we're just crossing numbers using the periodic table next. Let's imagine that the question's asking us to add magnesium to oxygen. They might ask you this as a worded question, or they might just ask you this with the chemical symbols. The first thing to do is to find magnesium and to find oxygen. Now, when you find them, have a look at how many bonds they want to make. So I can see that my magnesium wants to make 2 from the work that we did earlier, and that oxygen also wants to make 2. So let's write that in. So magnesium wants to make 2 bonds and oxygen wants to make 2 bonds. And what we do is we then cross these over. So we cross and we cross. And what we'll end up with is we'll need 2 magnesiums for every 2 oxygens. And so we just write that as MgO, or magnesium oxide. And if you're asked to answer this as a worded one, it's magnesium oxide. And you'll have to try and remember that when you write oxygen or most of the elements from the right-hand side, of the table out, they change their name. So oxygen becomes oxide, chlorine becomes chloride, fluorine becomes fluoride, for example. Let's have a look at another example. This time we'll have a look at aluminium plus sulfate. Now the first thing that might stand out is that it's not just, we've got aluminium, which is a nice straight element to try and find in the periodic table. It's sitting over here, but sulfate is not. And it's not the word sulfur, it's sulfate as well. So if you're not given the chemical symbol and it doesn't sound quite right, go to your formula sheet for chemistry or science if it's your test, or flip your periodic table over and on the back have a look and see if you can find sulfate. These are called polyatomic ions, and what they are groups of elements that have formed covalent bonds. We don't need to worry about covalent bonding in year 9 and 10, only ionic bonding. But what you're looking for is you're looking for that little 2- there, because that tells you the valency, or how many bonds that sulfate wants to make. So just like in the first example, aluminium wants to make 3 bonds, okay? Remember we got that from those notes that we'd made. And sulfate wants to make 2 bonds. And we got that from the valency table up here. And what we'll do is we will cross those over like we did in the first example. So when we go to write this out, we end up with aluminium with a 2 instead when we crossed over, and then sulfate with a 3. Now to keep it all together, we need to put brackets around this, okay? Because that means that what you've got is you've got 2 aluminiums, you've got 3 sulfurs, and you've got 12 oxygens. So the little 3 down here multiplies the elements that are up in the brackets. And then again, if you're not sure about the names of these, you should use the valency table to help you, okay? So this one is aluminium sulfate. Hopefully that helps you. If you're not sure about the periodic table or how I went about drawing those atoms, just duck back to the other videos and watch those ones to get a rundown on that.